Thank you and welcome to Ascending Grades. Thank you for trusting Ascending Grades as your online school where you can elevate your grades and touch by elevating your tomorrow or your future. So today we shall be discussing on a post-mock paper, physics theory, a post-mock of Kapsabet High School. So in case you have or you require any assistance, you can get me through 0757 01 9011. Feel free to text, call, or WhatsApp. We highly value your feedback. We highly value your inquiries. So, this is the paper. We have already done the section B, but for today we shall be looking at the section 1. Section A, which comprises of 25 marks. So this one is already done and uploaded. So what is remaining in section A? So let's go straight to question 1, which is about a measurement. You know that the figure below shows a vernier caliper taking the length of a rod whose correct length is 25.4 millimeters, 25.4 millimeters. Remember, we are talking of vernier. So we know that vernier caliper gives readings in centimeters. So the first thing, we convert 25.4 into centimeters, and this becomes by dividing by 10. And this is supposed to be reading as 2.54 centimeters. So I can say 2.54 centimeters as the correct length of the rod. Here is the rod. So you have to determine the zero error for the same. So the first thing is to look at the reading of this one first. So what is the reading? Reading of this vernier caliper. We can see that from the main scale, this one, the mark that is left of the zero mark of the vernier scale is 2.1, 2.2, and then we have 2.3. So we can say it is 2.3. Then the one for vernier scale, a mark on the vernier scale that is coinciding with another mark on the main scale. You can see we have 1, 2, 3, 4, 5, 6, 7, 8. And the eighth point, we can see that it is coinciding with another mark. Then you multiply it with a least count of 0.01, so it becomes 0.08. So the reading of this vernier scale, vernier caliper, is 2.38 centimeters. Now, we have the real question here. We have now the real question here, which is asking, determine the zero error. Determine the zero error. So, remember, for us to get the actual reading, NB, actual length can be given by the reading plus or minus the error. So if it is a positive error, so if for a positive error, we subtract the error. If for a negative error, we add the error. So from this section, we can now ask ourselves, what error will it be? So you can just choose to look at the real one is this. So you say we have 2 point, the actual length is 2.54. And then will be given by the reading which is now 2.38. Then you ask yourself, for us to arrive at this one, should we add or subtract? Let's say a value x. Let's suppose we say a value x. So if you look at this one, we will be supposing to add something. We're supposed to be adding from this, we are supposed to add x. So now our equation will change. Now it will be 2.54 is equals to 2.38 plus x. So my x becomes 2.54 minus 2.38, and I get 0.16 centimeters. And this one will be a negative, the error now will be a negative 0.16 centimeters. Why? Because it is added. Or the other thing is that you can see where the zero mark of the main scale is. You can see where the zero mark of the main scale is. So it means that it is already making a reading ahead. So you have a negative 0 error. So now we can proceed to the question 2. The figure below shows two drums, A and B, and you're told that drum A is empty while drum B has a cylindrical rod. Then you're told if the two drums are given the same rolling force, state and explain which drum stops first. So let's look at the issues to do with moments. So B, it has a smaller moment of inertia due to the mass concentrated at its axis. So this one, we are having some weight concentrated at its axis. So this one will make this one to move a shorter distance. So we can now start explaining. B stops first. So B is supposed to be the first answer. Now we need to explain. It has smaller momentum of inertia. Why do we say inertia? Because this body will keep concentrating on the base due to mass concentrated at its axis. At its axis. So it resists motion for a short time. So B is the one that will be moving a shorter distance, or short, it is going to stop very fast. We have question 3. There is that an astronaut weighs 500 newtons on Earth and 8 newtons on the surface of another planet. Given that the gravitational field strength of the Earth is 10 newtons per kg, calculate the gravitational field strength of the planet. So, what are we supposed to look at in this case? The first thing is using Earth. We are supposed to get the mass of this astronaut because mass is constant everywhere. So from weight is given by mg, then our m can be given by the weight over g. Therefore, we have our 500 divided by 10. And in this case, we are going to get 50 kg as our mass. Therefore, since this one is held constant, now you can use on the planets, you can say that our mass is 50 kg, then our weight is 80 newtons. Then now we are looking for our g. Therefore, from weight is equals to mg, our g will be given by weight over m. So this becomes 80 divided by 50. And this one is going to land as 80. So must be 50. 80 divided by 50. Let me visit it. It's supposed to be 80 divided by 50. So you get 1.6 newtons per kg. Meanwhile, allow me to rectify some working over here. This was supposed to be 80. So now, meanwhile, we are thrilled to have you on board for the December holiday, where we shall be engaging on the sciences and mathematics. It is a 5-week program running from 11th up to 12th, 11th of November up to 12th of December. Then, through the number that is appearing on the screen, you can inquire to this best online platform where we can engage, keep your son or daughter very busy. This is not limited to high schoolers. You can also, we are also enrolling the junior school and also inviting a special guest of grade 6 because they will be joining grade 7 come next year. They need to get familiarization with this platform. So now we can move on to the next part. In order to estimate the height of a tree, a student measured the length of a shadow and found it to be 3.2 meters. A meter rule that she had produced, that she had, produced a shadow of length 240 centimeters. What is the estimation of the height of the tree? So we all know that estimation of the height of the tree can be given by the height of tree over the height of rod. Now in this case, we are going to use the rod that is being used here is the meter rule. Will be the same as the length of the shadow of the tree over the length of the shadow of meter rule. So it's like saying the height of tree, HT, will be given by the meter rule. We know that it is 1 meter is equals to the height of the length of the shadow of the tree. We are told that it was 3.2 meters of the length of the shadow of the meter rule, which was 240 centimeters. This is equivalent to 2.4 meters. So divided by 2.4. Then the height, HT, if we make it the subject the formula, then it becomes 3.2 divided by 2.4. This gives me 1.333 meters. From reality, you can see that a tree cannot have just 1 meter, but because it is just the working, then we need to appreciate and trust our calculation that we shall be having a tree of 1.333 meter. The figure below shows two identical containers, A and B, containing equal amounts of water and an identical ice block. State with reason which water cools faster, assuming the gas absorbs negligible heat. So we all know that the gas is used to make the ice to sink. Then we are assuming that it is not as absorbing any substantial amount of heat. So in air, since the ice is floating on water, then we do expect the top water to be cooled, increase in density, and then it is going to move down. In short, it is going to create convectional currents. So we expect that at A to cool very fast. But in B, the cooling will only be occurring at the bottom. And since there will be no issue of change in densities, even if there is change in densities, the water at the bottom will become more denser, but it cannot move upwards to displace the less, it cannot move upwards to displace more water to keep coming down. So there will be no convectional currents in this one. So that is why it will not have some efficient cooling. So you can say A will cool very fast because water at the top cools faster creating convectional currents. So cold water moves down, unlike in B, where it stays at the bottom. Where it stays at the bottom. Or you can say it remains. Mm-hmm. I thought to sketch a graph of P against the reciprocal of the mass of an ideal gas. So this one is just the Boyle's law, which says that the pressure of a fixed mass of a gas is inversely proportional to its volume at a constant temperature. So it is a straight line passing through the origin. So we have pressure P here, and we have the inverse of volume. So this is a Boyle's. Maybe I can remind the pressure of a fixed mass of a gas is inversely proportional to its volume at a constant temperature. So now we are told to state the physical quantity represented by the gradient. We are going to have a very long story here, but I'll try my level best to make it very short. This is not of our level of the scholars. The equation is supposed to be PV is equals to the number of molecules times R times T. So making P the subject formula, it becomes nRT over V. So if you break this one down, then it gives P is equals to nRT 1 over V. So this one now becomes our gradient because the equation will have much y is equals to mx plus c. Our c is 0. Then our x becomes 1 over v. Then this becomes our nRT. So our nRT is supposed to be giving us the energy. The energy of the molecules or the particles. We have question 7, which says that the figure below shows two pipes, A and B, of different expansivities fitted onto each other at the junction. When some ice was placed at the junction, it became easy to separate the conductors. So now we place some ice around this place. So now we are placing some ice at the joint. Then we are asked, explain which of the two was a better conductor of it. Now in this case, for the good thermal conductor, we are looking at the rate of absorbing, no, the rate of contracting, the rate of contracting. That is what we are considering. So if it became easier for the two to separate, then it means that since the outer one, since air is outside, if it contracts, then it will tightly lock. So we put an X on A. So our B becomes automatically the answer. You can say B is a better thermal conductor. Why? Since it contracts, or you can say it contracted at a faster rate. Contracted at a faster rate. So now B carries all the way. We have question 8. You are told that the figure below shows a Bunsen burner. And you are told, explain how air is drawn into the burner when the gas tap is open. So we open this. So we expect air to be moving upwards. That is the gas. It will be moving upwards. And then what next happens is that from the jet or the nozzle, it will be at higher velocity. The gas will be moving at high velocity. So it's like inside the barrel, there will be increased velocity, and this one will lower the pressure. So if the pressure inside the barrel or the chimney will be low, then higher atmospheric pressure outside will force air into. If we can say, as the gas enters, the chimney, it moves with a high velocity at the nozzle, creating a low pressure zone. Then you're told higher atmospheric pressure forces the air into the chimney through the air. We are told define Brownian motion. Is the continuous random motion. Is the continuous random motion of particles or molecules. Naturally, whether in solids or gaseous or in liquid state, particles are in continuous random motion. Now we can continue to part B. The figure below shows apparatus used to observe the behavior of small particles in a small cell. Then you're told, state one reason why smoke is used in the experiments. We may discuss several issues because the question seems to be just targeting one part. So we'll answer it and then have several other things. So we have the microscope as shown. We have the smoke particles, we have the smoke cell, we have the beam of light. So the reason as to why smoke particles are used is because they are visible. They are visible. They are light and visible. So we can combine those two terms. They are light and visible. Then we can have some other questions. Use of one, the beam. So is to illuminate the smoke cell. We have number two, the use of the microscope. Microscope is used to magnify the smoke, used to magnify and observe, used to magnify and observe the smoke particles. So those two are very correct. In other times, we can be having a convex lens. This one, we can say a convex. Then what will it be used? The convex lens is to concentrate light into the smoke cell, like that. Three identical springs, each of constant 10 Newton per meter, weighs 0.5, that are used to support a load as shown. So we are having this one. we are told that each spring weighs 0.5. So this one will be of 0.5. This one is of 0.5. And this one is of 0.5 newtons as weight. So you're asked, what will be the total extension? You can see we're having a spring constant of 10 newtons per meter. Then we have a weight of 6 newtons. So the first thing that we're supposed to look at for spring A, the weight that will be acting, on it will be the 6 newtons plus the weight of these two springs, this and this, 0.5 plus 0.5. So in this case, we are going to get 0, that is 7, supposed to be getting 7 newtons. Now, what will be its extension? We know that K is equals to 10 newtons per meter. Weight, now we have weight or force is equals to 7 newtons. So what will be the extension? We know that the extension is given by K. Is it force over K? Yeah, force over K. Force over K. So this is 7 divided by 10. You arrive at 0.7 meters. You can call this one E1. E1 is equals to 0.7 meters. Then, now say for B and C, then the weights will be 6 newtons only. Then, since they are 2, we shall have combined spring constant, which will be 2 times 10. I repeat, for B and C, they are in parallel. So the effective spring constant will be twice the spring constant of one spring. So it will be 20 newton per meter. We have a weight of 6 newtons. So what will be our extension E2? So our E2 will be given by 6 divided by 20. And this arrives at 0.3. Uh-huh. 0.3. Okay, so this one becomes by 2, 3 by 2, 10, 0.3 meters. So E total will be E1 plus E2, 0.7 plus 0.3, arrive at 1 meter. So that is how it's supposed to be like. So we get 1 meter. Allow me to have this one on board. We are thrilled to have you on board come the coming holiday for our online engagement, our online school. We'll be offering sciences and mathematics running from 11th November up to 12th December, a 5-week program. You can inquire and start enrolling as early as now from or by contacting 0757 01 90 11. Thank you so much. So now I can continue. We are now in question 11. Other than friction in a screw jack, state the reason why it can't be 100% efficient. Some part of the applied efforts stock energy is lost as it and sound during operation. You can have another reason. Some work is used in overcoming the loads. Overcoming the loads, weight along the helical path. Remember, we have the threads that are in helical manner. We have a question that says, a YouTube mercury is used as manometer to measure the pressure of a gas in a container. When the manometer has been connected and a tap opened, the mercury in the U-tube settles as shown in the figure. And now you are told, if the atmospheric pressure is 760 and its density is 13,000 kilograms per cubic meters, calculate the pressure of the gas in pascals. The pressure of the gas in pascals. If you look at this one carefully, the atmospheric pressure will be acting in this manner. And then it is working against. We're having a small portion of extra height here. We have a smaller height column that is acting against the pressure, which will be 2 meters. 2 meters of the mercury column. So the pressure of the gas now here will be given by the ATM, atmospheric pressure, minus pressure due to mercury column. With this one will be given by I rho G. But since atmospheric pressure we are given in terms of millimeters of mercury, we can say atmospheric pressure will be as a result of, this one will be as a result of the height due to air column, or you can say ATM, height of the ATM minus the height of the mercury, height of the mercury, then you multiply by the density times G. Therefore, the height of atmospheric pressure, it is 760 millimeters, which is equivalent to 0.76. Minus, I'm going to do some changes here. This was supposed to be 2 centimeters. So 2 centimeters here will be equivalent to 0.02 meters. Then we multiply by 13,600 times 10. Here we go. By calculation, then this is a 0.76. So this is 0.74 times 13,600 times 10. And this becomes this becomes 100,760 pascals. The question is asking in pascals. Remember, 1 Newton per meter squared is equivalent to 1 Pascal. So we go it by this way. Atmospheric pressure. But we have some mercury column that is acting against. Since this one is pushing down, it is working against the atmospheric pressure. So that marks the section 1, the section A, sorry, of the physics paper 1, the Kapsabet post-mock exam. Those who are preparing for the Kcse, we are wishing them all the best in their upcoming exams. Meanwhile, we are thrilled to have you on December through this online program. Ascending Grades Online School is here to have you for 5 weeks non-stop engagement in mathematics and science studies, physics, biology, and chemistry. You can start enrolling now through 0757 01 9011. Thank you so much. May God bless you.